In the name of God, the most gracious, the most merciful, all praise be to Lord, the Lord of the worlds, the most gracious, the most merciful, King of the day of judgment. Thee alone we worship and thee alone we seek for hope. Show us the right path, the path of those who have bestowed your mercy, not the path of those whom you have cast, nor the path of those who are strong. O Lord, accept our prayer. Amen.
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 Amen. Thank you so much for the word of prayer, the Galvanians, and you're most welcome, everyone. Good morning. We are still looking at patterns and algebra, and today our major area of concentration, the first number we are going to deal with is going to be about the quadratics. Now, under this topic, I want us to understand one thing. One is that whenever you meet a quadratic equation, we have a quadratic equation, and we say that a quadratic equation always is in this form: ax squared plus bx plus c equals to 0. Now, when you meet this kind of equation and they have asked you to go on and draw it or put it or show the path that is being taken, always I want you to look at the coefficient on x squared. This coefficient shows you how your shape must look like at the end of the day. Whenever you find that a is positive, being positive, in other words, if a is greater than 0, that greater than 0 means it is positive. Take an example. If I have 2x plus maybe 2x squared plus maybe 4x plus anything, maybe 8 is equal to 0. The moment I check out that this coefficient here is positive, because here my a is 2, it means that my graph is going to look like this. Always, for the moment you check that, and if it looks like this point down here is what we shall be calling the minimum point. So that means that for such a graph, they'll be asking you to find a minimum point. So always check out, if this one is positive, then it means that your graph, even if you make a mistake, even if what happens, your graph must always look upwards. When your A is negative, if your a is negative, say a is less than 0, what does it mean? It means that if it is less than 0, take an example, you have maybe negative x squared plus maybe 2x minus 5 is equal to 0. The moment you read the coefficient on x squared, now for such a case, it is equal to negative 1. The moment you find out that it is negative, then it means that now your graph is going to give you a maximum. So your graph must look like that. So in case you draw your table, you come up with your graph and your graph doesn't look like this, then it is an indicator that you have made a mistake somewhere. And for such graphs, they will always give us the maximum point. Then still on this graph, they can ask you, what is the maximum point or what is the minimum point? So in order for us always to get the maximum point is that point where our graph turns. This point is called the turning point. The turning point, whenever they ask you for that turning point, you can as well calculate it using this formula that x is equal to negative b out of 2a. Now this is the equation you can use in order for you to obtain that maximum point. So whenever they ask what is the maximum point or at what point does the graph turn, then it is this. In case they have asked you the coordinate, then it means that you obtain your x first, and then after obtaining your x, you can go on and obtain your y by feeding back in the equation. Still here, they can ask you for the line of symmetry. Line of symmetry is that point at which the graph divides it into two equal parts. Still, this line here is given by obtaining that maximum point. So that line is always also given by negative b out of 2a. Now this is what is very important. when it comes to graphing these quadratic equations. So whenever they ask you, just look at the coefficient. Then after looking at the coefficient, you can go on and then start knowing how your shape is going to look like. Okay, I think, are we good to continue? Anyone with a question on this? If we are going to continue, you can let me know and then we continue to start. Okay. Proscovia, maybe you can first let me know. Yes, Proscovia. Yes, Marie. I didn't pick your question well. You are saying? Oh, unfortunately, you are breaking, so I didn't pick your question well. Maybe place it in the chat. I can pick it from there.
Good
Okay.
morning, sir.
Yes, good morning.
My question, I need you to elaborate more on that, how to get the maximum and minimum point on that equation.
Okay. Assuming that this is your equation here. So what you do, you extract your A, that my A is -1, my B is equal to 2. So to get that point, you just come and say now my X is equal to -B out of 2A. Then you substitute that this is negative. My B here is going to be 2 out of the 2 times -1. So this will be -2 out of -2, which is equal to X is equal to 1. Now it means that the point, the X point, where your curve is going to pass here must be 1. When the point where your curve turns here, down here, along your x-axis, you'll have 1. That is the meaning. Hope you have picked. Okay. Now we can now start. Now, there is this number. It was from UTech. Now, the number, they told us that this is UTech. So they told us that in a mango village, poverty was at its peak. Therefore, a vibrant youth group launched a small-scale enterprise under the Youth Boost Elevation Project aimed at reducing unemployment and empowering rural youth through entrepreneurship. They ventured into making and selling handmade bricks using local materials. During the first 5 weeks, they recorded the number of bricks sold and observed a consistent pattern in their weeks. Now, remember, this element of construct here where we are, it has an element of what we call number sequences. Now, when you are dealing with number sequence, there are mainly two patterns that you can obtain. And those patterns are, we have what we call the arithmetic progression. Under arithmetic progression, this is where you have what we call a common difference. That between any two numbers that you have, the difference is the same. That's what you call arithmetic progression. Take an example. If I have 3, I have 9, I'll have 15, I have 21, and so on. Can you let me know, when you look at this pattern here, is the difference the same between the two digits? Let me know through the chat. Is the difference the same? So I'm waiting in the chat to tell me, when you look at 3, 9, 15, 21, could the difference be the same? And if it is the same, what could be the difference? Mark has told me, yeah. So people are noticing, very good. You are noticing that between 3 and 9, the difference is 6. Between 6 and 15, the difference is 6. Between 15 and 21, the difference is 6. Now, the moment you discover that the difference is the same throughout, then this one is called an arithmetic progression. Now, this one here, the first element is what always we call the first term. Now, in order for you to be able to get the nth term or to be able to calculate any term that you want to obtain, we can come here and say that the nth term, I can use Tn is equal to A, whereby A is the first term plus n minus 1, then times D. D is what we call the common difference. It's called a common difference. And n is what we call the nth term. And A is what we call the first term. So if they ask you, you get for us the nth expression, you get us this and this for the nth term. For you, what you do, you come here. Where there is A is the first term. For such a case, it's going to be 3 plus n minus 1. So n minus 1, you leave it, times the difference. For this case, it's going to be 6. Now, here, you always go on and simplify. Whenever they ask for the expression, they're asking you, do you have something that we can use, the pattern that we can be looking at and we obtain other numbers? So when you come here, we are going to open. So this will be 3 plus. This 6 affects the 1. This 6 affects the n. So we shall say 6 times n minus 1 times 6, which will give us 3 plus 6n minus 6. Then you can go on and reduce or collect like terms. So I have 3 minus 6. So I will say 3 minus 6 plus 6n. 3 minus 6 is equal to negative 3 plus 6n, which you can see write as 6n minus 3. Now, this is what you call the expression to find the nth term. So whenever you want any term for this particular sequence, it means that you are going to just say 6n minus 3. And here you go on and tell us your n, that for n starting from 1, 2, 3, and so on. Now, this is what we call the expression for any term within the sequence. So when you go back and say, when my n is equal to 1 and you place here in the equation, you'll find out that you get 3. When your n is equal to 2, you'll go back and check that you get this. Kindly let me know whether now we're on the same page. You first test which kind of progression do I have? Is it arithmetic? Is it geometric? Okay. I'm just checking in the chat. Okay, people have said yes. Okay, now I come back. This one was just a review on what we are going to look at. Now, I want you to tell me, they are telling us in the first part that find an expression for the nth term of the sequence. Now, when you look at the sequence they want us to find, they are looking at the one for the brick sold. That in the first week they sold 250. From there they went 270. From there they went 290. From there they went 310, and so on. Now you check out this, which kind of progression do we have? What is the difference between the numbers? Kindly let me know through the chat. Is this an arithmetic? And when you check out, is the progression? What is the difference between two consecutive? Very good. Now everyone has been able to see that the difference from week 1 to week 2 is 20. The difference between week 2 and 3 is also 20. 3 and 4 is 20. 4 and 5 is also 20. Now, the moment you find out that this is an arithmetic progression, then do not always waste time checking how can I get it. You come back to the formula for an arithmetic progression. So now we are going to come back. I'm going to first write my sequence very well. I'm going to first write my sequence very well, starting from 250. 250, I go to 270, I go to At 290, I go to 310. So you are going to allow me do like this. Going to allow me do like this. I create some space here. Yeah. So I'm going to come here, and now we know our sequence. Our sequence was 250. It went to 270. It went to 290, and then it went to 310, and so on. Now, this first one is what we always call the first term, the first one. So, and we have said that our formula, we shall just say A plus n minus 1 times d. And we said d means the common difference between the two numbers. And a is always your first term. First term is that which digit have they started with. But always, before you test, you first test whether the sequence. Now here our a is the first term, which is equal to 250 plus n minus 1, then times the common difference, and you told me the common difference was 20. So from here, we are going to open. So when you open, you'll have 250 plus, we have said this 20 will affect this 20 will affect this. So it will be 20 times n minus 1 times the 20. So which will give us 250 plus the 20n minus the 20. So from there, wait. So from there, we are going to continue and now correct the like terms. So when I'm correcting, it means I'll have 250 minus the 20 plus the 20n. So this will give us 230 plus the 20n. And now here, when you reach here, you always go on and tell us for our n values starting from 1, 2, 3, and so on. Kindly let me know whether that is very okay. Favor, that is correct. Is that okay to everyone? Okay, very fine. Hope the Gavanians, we are on the same page. Okay. So we are going to go on now and answer the second part. So the second part told us that use your expression to calculate how many bricks they would sell in week 10. So in week 10, it means that you are going to substitute. Now, what are you going to substitute? Now, when you look at our expression here, it would have been much better where we have used the n to have used the x. It would have been better that way because your n, so here you will define and say, let n represent the number, let n represent the number of weeks. Yeah, or you can define it that way. Then from there, we are going to send to come and say now for week 10, or when I'm calculating for week 10, so where that means that your n will equal to 10. So you substitute. So we say that this is going to be 230 plus 20n. Can everyone first put your answer? Where there is n, put 10. So put in the chat which answer you are getting. According to Favor, 430, Sage, 430, good. So everyone, can we check out whether that is the answer? Very good. So our n we said is 10. Yes. Abby, that is okay. Kathy, yeah. So, Kathy, how did you get to 39? Kathy, check out that you also get 430. 430, very good. So then after you make your conclusion that at the end of the 2 of the 10 weeks, they will have sold 430 bricks. So do not forget always to go back and respond back to the question that at the end of the 10 weeks or at the end of the 10 weeks, they would have sold 430 bricks. Okay. I think we are good to continue. However, as well, allow me to bring it to your attention. This time, it was an arithmetic progression. Next time, you may find what we call a geometric progression. Now, under geometric progression, take an example. You can have things like 2, 4, 8, 16. Yeah. Who can, when you check out this, what is the pattern between those numbers? When you check out the sequence I've given you, what could be the pattern? I'm checking. If you have discovered the pattern, even if you can feel free to raise up your hand and you share with us. 2, 4, 8, 16. So, okay. Let me take on Eric. Yes, Eric. Eric, you can unmute. It is?
You multiply by 2.
You multiply by 2. Very good. So I don't know if everyone is noticing that. To get to here, they are multiplying by 2. To get here, they are multiplying by 2. To get here, they are multiplying by 2. To get there, they'll multiply by 2. Very good. Now let me give you another one such that also people can. Thank you, Eric. That was okay. What if we have this? 1, 4, 16, 64. Yeah. When you look at that pattern, what could be the pattern? Make sure that the pattern you get works for all. You can put for us in the chat quickly. You multiply by 4. Let's see. Multiply by 4. Good. Let me give you another one. 3, 6, 12. Just drop for me the next two if you have understood now the pattern. For number 3. Number 3. Number 3. Number 3. Drop for me the next two terms. Okay, now I'm just checking in the chat. 24 and 48. That is very good. So now, for these patterns that you find when you are to get the other, you multiply. To get the other, you multiply. These are what we call geometric progression. And when I want you now to test for me, to test for me the ratio between any two consecutive digits and tell me what your findings are. If you test for these progressions I've given you where you are multiplying, the between two consecutive digits, the ratio, what are you finding out? I want you to get 2 digits and then Magezi says 1, 2, favor 1, 2, 1, 2. Between any two consecutive digits, 3 to 6, 3 to 6, 3. I don't know whether you are finding out that when you get any two consecutive digits, the ratio is the same. When take an example, when I say 4 divided by 2 here, I'll get 2. When I say 8 divided by 4, I'll get 2. When I say 16 divided by 8, I'll get 2. Not so? 2 to 1, 2 to 1, like that. Now, for such numbers whereby here you look out for what you call the common ratio. That's what you look out for. Is the ratio the same between any two consecutive numbers? When I divide, do I get the same thing? If that one happens, then that means you are dealing with what we call a geometric progression. And now for such a case, to get your formula, for it, we always get it in this form, a r n minus 1. That's how we get it for a geometric progression. So when I have 2, 4, 8, 16, what I do, a is the first term, so I write it as 2. Then r is the common ratio, difference between the two numbers. So I get 4 and 2, I say 4 divided by 2 is equal to 2. So my r is equal to 2. So here I will say times 2, then power n minus 1. Now, to go away from here, you use your knowledge of indices that this number here is to power 1. So you know that in indices, when numbers have the same bases, I can add the power. So I can say 2, 1 plus n minus 1, which will give us 2, 1 minus 1 is 0, which gives us 2 to power n. Then you say for n equals to 1, 2, 3, and so on. So this is now your formula for the nth term. Are we on the same page, everyone? Is that okay? I repeat, I've said that when it comes to a geometric progression, to be able to get any term you want to get, the formula will be a r n minus 1. R is the common ratio between the two. Take an example. If I give you 1, I've given you 4, 16, like that. Here the first term a is 1. So where there is a, I'll put 1. Times r is the common ratio. The difference, the ratio. So I say here, I get 4 divided by 1, which is 4. Alternatively, you can get 16 out of 4, which gives you 4. So where there is r, you put 4, then n minus 1. Now, 1 times anything is that same thing. So for such a case, you get 4, n minus 1. Let me hope now we are on the same page. Now, can everyone quickly do for me this one at least? And I check whether at least we have picked something. Imagine your pattern was like this. Can we drop the nth term, the formula for the nth term? Try it out there on the paper and we see what you get. For some, you can simplify. Some cannot be simplified. So in case things are not simplified, do not struggle to try to simplify. You leave it like that. Hey, it is here favor. This one. Yes, Abby, that is okay. Okay. 3 power n. Now, remember, here, I know people are getting this, 3 times 2 power n minus 1. Now, members, for this, you may not be able to simplify. Because remember, this 2 has a power of n minus 1. So these ones are not the same bases, so you can't multiply. So for such, you can just stop there. There's any way you can continue from there. Alternative, the other alternative is another one, but this is where you end. There's no need now for you to struggle. Yeah, so you cannot multiply 3 times 2, yet this one has the power, this one has the power, so you can. But also do not forget, always test your formula after. Test your formula. Now take an example. If I'm to use for Salome, 6n minus 1. When your n is equal to 1, you'll get here 1. So to be 6, 1 minus 1, which is 6 power 0, which is 1. Yet your first term is not 1. Yes. So for some, you may not be able to simplify. You leave it there. The moment you check that this first one here is not resembling this, the bases are not the same, then don't struggle with it. Leave it the way it is. Hope that is okay, everyone. So, yeah. So people who gave us 3 to power n. When you look at it, when your n is equal to 1, it will work 3 power 1, which is 3. When n is equal to 2, it will give you 3 power 2, which is 9. So which is not 6. Yeah. Let me hope now we have got. I repeat, looking at the pattern we have at hand, our pattern is 3, 6, 12, 24. The ratio between two digits is 6 divided by 3, which is 2. And we have said we are going to fill in AR n minus 1. Now what you do, A is the first term, which is 3, times R, which is 2, power n minus 1. Now for such, you cannot use your indices to solve, or you cannot continue. Remember, indices to work, a to power m times a to power n can only work when the bases are the same. But for such a case, the base here is 3, the other base is 2 power n minus 1. This is to power 1. So since the bases are different, there is nothing you can do. You just stop there and leave it like that. The other one was possible because here we had it 2 and here we had it 2. So that is when you can go on and simplify. Because this is 2 to power 1, the bases are the same, I can add the powers. I don't know whether now it is okay. No. Now here it's not a common difference. I've told you we have 2. We have an arithmetic progression. That is where you have the common difference. Then there are times when you are going to check when the difference is not the same. So for such a case, we call it a geometric progression. Then that one, you look out for the ratio. I don't know whether Eric now it is fine. Okay. Hope now it is okay to everyone and okay. It is okay. Yeah. So you need to always to check out, is it arithmetic? Is it geometric? Yes, even it can come in form of fractions. So you need to check out. Okay. Then we can now move on to the second part of this question, which wanted us that using a scale. Now I'm going to still to first test whether people were attentive. Now, mere looking at this is our quadratic curve, which is y is equal to negative x squared plus 12x plus 20. They are telling us to draw it. I'm going to have two shapes here. This is my shape A. This is my shape B. Just mere looking at the equation, how do you think your graph will look like? Put in the chart either A or B. And we see which people are paying attention. Very good. Very good. Yeah. People are paying attention. Yeah. Yes. So it's going to be A. Now, this negative, it shows you that it's going to look in the negative side, The negative, because you know negatives are down, Yeah. So down. So it will be like A. It will look like that. Now, the moment you make your sketch, you draw it and doesn't come like this, then it means there is something you are not doing right. Okay, so we are going to start on this number. Now, when you look at this number, though, before we start, we shall not, I want to just let you know, we are not going to be able to complete it, or I will not complete it, because I noticed something not okay with it, so we shall not complete it. But I'm going to show you the basics you need to know when you are attempting such. Now, when you are attempting such a number, one, always, in case they have given you a scale, please on your graph use the scale that has been given to you. In case they have given you the domain, the values they want you to use for your table, please use them. Now they told us to draw these graphs and they gave us the domain, the x values they want us to have from 0 to 12 inclusive. 0 is inclusive and 12 is inclusive. So we are going to first draw our first graph here, which is y is equal to negative x squared plus 12x plus the 20. Now, when you are doing this, always have a table first. So I'm going to draw my table. This is going to be my table. And always I start from x. So they told us that our x values run from 0 to 12. So I'm going to say this is 0, this is 1, this is 2, this is 3, this is 4, 5, 6, 7, 8, 9, 10, 11, and then up to 12. This is our table we have. Now, I don't know how your teachers taught you, but I'm going to use two approaches here. Number one, when you have such a quadratic equation, you break it into different parts. How am I going to break it? When you look at it, this quadratic is starting with negative x squared. So I'm going to start here, my table, to break my table with negative x squared. That is the first thing. Then, when you look at it again, it has a 12x. So I'm going to break here and I put 12x. Then from there, I have another one, which is the 20, a plus 20. So here, I'm going to have a plus 20. Then the last one here, I'm going to have the last one. When I combine these three here, I must be able to get my y. Kindly let me know whether we have understood. I'm turning this equation from horizontal to vertical. So let me know through the chat whether that is okay to everyone. Okay, people are saying understood. Okay, yes, it is okay. Now, why do we break it like this? This one helps you to have your work very organized, such that you avoid making errors for computation at once. Now, from there, I'm going to continue. Milton, I don't know whether you can unmute. Milton, I don't know whether you can unmute. Milton, unmute.
Morning, sir.
Morning.
Thank you for this opportunity. So I just wanted you to pardon from negative y squared
Okay. Now let me give you
to the value of y.
in case we had this. Are you seeing this?
Yes.
Yeah. What we do, instead of writing it horizontally, I turn it and I write it vertically. That we had x squared, I'll have x squared. This is plus 2x, I say plus 2x. This is negative 5, negative 5. Are you getting it?
Yes, sir.
Hey, we are turning the horizontal to look vertically.
All right. Thank you, sir.
Okay. So this is what we are going to do. Now, the first one, I want you to always pay attention. The first one is negative x squared. But your x here is 0. So it will say negative. Put a bracket, please. Put a bracket, 0 squared. So this will be negative 0. But 0 is a neutral number, so which is 0. The next one is negative x squared. We shall have negative. Put a bracket for that x squared, 1 squared. Now 1 squared alone is 1. So I'll have negative 1. Yeah. So can someone now, I want someone to raise up the hand and then you complete for us the table. Raise up the hand and then you complete for us. I want someone is going to complete for us the first one. Yes, and the rest you should also be completing. Okay, yes, Favor.
For where x is 2,
Hmm.
it will be negative 4.
Negative
4.
4. Mm-hmm.
Then the next will be negative 9,
Negative 9. Mm-hmm.
negative 16,
Mm-hmm.
negative 25,
Mm-hmm.
negative 36, negative 49, negative 64, negative 81, negative 100, negative 1 to 1, and negative 144.
Okay. Thank you, Favor. That is good. Now, to go to the next one here, we shall have 12 times x. But your x is here, this one's up. So you say 12 times 0, you get your value. To get to the next one, you say 12 times 1, you get the value. So someone is going to complete. Gavanian.
But Master doesn't pass up.
Yes?
94.
Now, Masters, I thought that when multiplying the other negative x squared, when finding the values of negative x squared, I thought we had to include the brackets.
We don't?
We had to include the brackets because even if you say that it means if one it was the x and I say negative 1 into brackets squared here, I get
Negative into 1 squared.
And I get a positive 1.
Oh, now remember here, we are only squaring the 1, not this negative. So it means you have this negative. Then square for you the 1. 1 squared means 1 times 1, which is 1. So you have not squared the negative. So remain with negative 1. There is a difference between these. What I didn't want you to confuse is this. This is different from this, what we have. Is it clear?
Yes, Master.
Okay, yes, let's have the Gavanians give us this law of 12x.
The first one is 0. 12
0,
times
okay.
12 times 1 is 12. 12 times 2 is 24.
Okay.
12 times 3 is 36. 12 times 4 is 48. 12 times 5 is 60. 12 times 6 is 76. 72. 12 times 7 is 90. Is it 84? It is 96, Master.
Yeah.
12 times 9 is 108. 12 times 10 is 120. Now 12 times 11 it is 132. 12 times 12 is 144.
Okay, thank you. Then the last one, the way we see it, that it is plus 20. So for it, yes, Marita.
Morning, teacher.
Morning.
I'm going to give the answer.
Okay, keep on, eh? You are going to give us
Yeah.
the y, right?
Okay, teacher.
Yeah.
Okay, teacher.
So now for this plus 20, everything you just say plus 20, plus 20, plus 20, plus 20, plus 20, plus 20, plus 20. Like that, like that, like that, like that, like that. So that's what you do. Now, at the end, one of the mistakes sometimes people do is when they're combining. Remember, in your combination, you have only 3 of these ones. So you just add them the way they are vertically. Add them the way they are, the way they are. Don't do anything. So you'll add 0 plus 0 plus 20. Hope Nicole that is okay. Then you add -1 plus 12 plus 20. Please do never include these ones here. Never be tempted to include these ones up here. So can we have, yes, Marita, give us.
Teacher, -1 plus 12 plus 21. It gives you
Oh,
160.
where have you started from? Okay. -1 plus 12 plus 20. This is plus, eh?
Yeah, plus 21.
Who is 20? Oh, what does it give you? Add for us. -1 plus 12 plus 20. What do you get?
-1 plus 12 plus
Mhm.
20 gives you 31.
Add well, add well. 31, eh? Okay, continue.
Then -4 plus 24 plus 22. 49. No, 4. See.
It gives you
24 plus 22. 42.
42. Sure. -4. Place it on the calc the way it is. Plus 24 plus 20.
Oh, -4
-4.
plus 24 plus 22.
So I'm
It
copying
is
some
giving
answer. It's giving
it is
you
giving 40.
40. So these ones, I've copied them from what people are putting in the chat. You come now to the sixth. -36 plus 72 plus 20. I'm copying. People are putting some answers in the chat, but you continue, Marita, and give us.
You've said 6
Okay, now for you, can you start from this backward, from the backward end?
from the 12.
Yeah. -144 plus 141 plus 20 from there.
-144 plus 144.
141.
141.
Okay. We can be using even favor. So
Teacher, I just wanted to correct that 141. 12 times 12 is 144.
144.
oh, here.
Yes.
Yes.
Okay.
That's a 20.
Down here.
Yes.
Okay.
Okay, teacher, at least I was finding a problem with my calculator. Let me.
Okay. So it is the calc. Okay, favor you can be giving us. So Marita, what's wrong with your calc?
I don't know. Like whenever I put a negative, like I add, it gives me like error. So let me get another.
Okay. So
Okay, so for 11,
hmm.
I have 31. Then for 10, which is 140 minus 100 gives us 40. Then 108 plus 20 minus 81 gives us 47. Then 96 plus 20 minus 64 gives us 52.
Like seriously.
Then lastly, 84 plus 20 minus 49 gives us 55.
Okay, thank you. So, Marita, I think you
Yes,
need to
teacher.
look out for a better calc.
Yes, teacher.
Yeah, such that in exams you do not get challenges. Okay. Now, this is our first table. Then yesterday I told that for anything you're going to put on a graph, you must go on and write the coordinates. So you write the coordinates that you have extracted. And when we are extracting, do not forget you extract the x, you extract the y. So allow me to extract them. I want to write them here for some purpose. So your x is 0, so I extract 0 and a 20. So I'll have 0 and then the 20. Then I extract the next one, which is 1 and then 31. I extract the next one, 2 and 40. I extract 3, 47. I will extract 4 and 52. I'll extract 5 and 55. I'll extract, now for you extract all, but allow me not to extract everything like that, like that. So up to when you reach the 12 and then the 20. So that is how you extract them. Now, after extracting them, what are you going to do next? Now, always, whenever like we have said, our curve must come down. I don't know that we are noticing that your values went increasing, they reached somewhere and then they started reducing. That should be always your pattern. They go on increasing, they reach somewhere, they start reducing. Now they start reducing when you reach the maximum point. That's when they start reducing. Now that is the first thing they wanted us. Now we are going to draw the second line. This is the second line they want also us to put on the graph. So I'm going to come and I put and we draw that line also. So I'm going to come and we draw that line again. Hope here I have space. So when I come here, I'm also going to draw my table. Still your table run from, this is your x, that is your x, which runs up to 12, this number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then lastly 12. Then what do we want to draw? Our equation is negative 2.5x. Y is equal to negative 2.5x plus 65 plus the 65. Also here, please, you are free to write your equation in this form, whereby you're going to say negative 2.5x there. Then you come say this is plus 65. And then lastly, you have your y. That one is also very, very fine. If you don't want for such, you can just find one. Yes, Saint Tomero.
Teacher, I just wanted to ask, one of our teachers said that if you can identify that it's a line, that you can just pick out two coordinates and then after plot them since it's a line. Is it allowed in exams or do you recommend that we do the whole up to 12 thing?
Now that one, Jean, don't go away. Now that one depends on the context that you are dealing with. Now, for such a thing will work only when let me say they have not given us the domain, the values of X they want us to use. That one is very okay. But the moment they restrict that to use this, then we must follow what they want us to use. Is that fine? Sentiment, is that fine?
Yes, fine. Thank you, teacher.
Okay, but don't go. Can you first give us at least the first ones here?
Okay. So this is 0 times negative 2.5x is equals to 0. And then plus 65, we put it in the second thing.
Okay.
Yeah. Then after the answer you get is 65.
Okay.
Then the next one is negative 2.5 times 1 is equals to negative 2.5 plus 65 is equals to, 62.5. Then we move on to the third one. We're going to get negative 2.5 times 2 is going to be negative 5 plus 65 is equals to 60. And after it's going to be negative 7.5 plus 65. You're going to get, done.
Okay. We are going to have also another person. You can start preparing.
You're going to get, sorry. You're going to get 57.5.
57.5. Okay. Thank you, Sentomero. Let's have Professor Emmanuel. So Professor is going to do for us up to 6, then we get another person. Yes.
So the next one, it is negative 2.5 times 4, which is equal to negative 10.
Oh, you are first doing up to the last one.
I started with the 4, from 4. Or I start from 5.
No, from 4. Then like you give it the way Sentinel has been giving us. Then down here.
Okay. It is plus 65, which is 55. Master.
Yes.
This one was negative 2.5 times 4. It was it was negative 10.
It was negative 10. So for me, just okay.
So
this is negative 10.
Yes, the value of y, it is 55.
Okay.
Yes. So negative 2.5 times 5, which is negative 12.5 plus 65, which is the value of y is 52.5.
52.5. Sure.
Negative 12.5 plus 62.
65.
Plus 65, which is 52.5. 52.5. So negative 2.5 times 6, which is negative 15. Negative 15 plus 65, which is 50.
Okay. Now let's have Bilonji. Thank you, Emma. Angel.
Good morning, sir.
Morning.
As I just wanted to continue where Yeah, stop.
Yes, continue, Bigunji.
Negative 2.5 times 7 gives us negative 17.5 plus 65, and then it gives us 47.5, and then negative 2.5 times 8 gives us negative 20 plus, and then down it is 45, and then 9 times negative 2.5, it gives us negative 225 plus 65, and then down it is 425.
Okay. Let's have also Gavanian. Thank you, Angel.
Welcome, sir.
Gavanian.
Good morning, sir.
Morning.
It is negative 2.5 times 10,
Okay.
giving us negative 25
Okay.
plus 65.
Mm-hmm.
It is giving us 45.
Oh. Add well, and we see.
Oh, it's giving us 40.
40.
11 times negative 2.5. It is negative 27.5 plus 65, 37.5.
Okay.
12 times negative 2.5. It is negative 30 plus 65. It is 35.
Okay. Thank you. Yes. Now, from here, this is where we go on and extract some of the code. You extract the coordinates, eh? Yes. So, but me, I'm not going to extract all. I'm going to just write here a few, 0 and 65. You extract your x and a y, x and a y. So this will be 1 and 62.5, 2 and then 60, like that, like that. Now, the next part, I'm going to give you the basics. Now, they told us here, this is why I want us to pay attention, the scale they used. They told that for every 2 centimeters, use 1 unit along the x-axis. Then, along the y-axis, 1 centimeter should represent 100 bricks. Now, what are you going to notice? Now, when you look at your graph, when you look at the graph paper you have, the graph paper, a standard graph paper for your neighbor, those graph papers for your neighbor that they will give you, they have, when you check, let me just draw it here. It is like this. So this side from here up to here has 20 centimeters. Up here, it has 24 centimeters in length. And width it is 20. So when you look at the one they want you that 2 centimeters should be 1 unit. You notice that here, because you have 20 centimeters, so when you say 20 divided by 2, you'll get only 10. And yet your x values are ranging from 0 to 12. So like it or not, it cannot fit. Now, for such a case, that is where you be creative and change your graph. So your graph, instead of having it vertically, that's now when you can go and have your graph horizontally. For it to be able to fit, because these are 24 centimeters, divide by 2, you can get the 12. So 12 can only fit if you change the orientation of your graph like this. So for this particular one, we shall change our graph to horizontal. Hope you have got the reason why we are going to change it, because it will not fit. Yet they want us to jump 2 centimeters. So from there, let me hope now that is okay. But these are rare cases after you noticing that it cannot fit. So you first reason out. Otherwise, you may draw your graph again and again and again, and things are not fitting. So here, we are going to come and have our lines drawn. So like I've told you earlier on that mine it will not fit, and I'm not going to force it, but just for your demonstration purposes. So I'll have my line like that, and I'll have another line like that. Something like that. Now, after having those two, I'll come here and I demarcate very well. I'm going to demarcate that this is my y-axis. This side, I have my x-axis. Now, for the scale, x-axis, they told you 2 centimeters should represent 1 unit. 2 centimeters are 2 boxes. So, from here, this is 0. 2 centimeters here, that one should be 1. These are 2 centimeters, those ones should be 2. These are 2 centimeters, this should be 3. 2 centimeters, those are 4. 2 centimeters, 5. 2 centimeters, 6. 2 centimeters, 7. Like that. You do the same. Now, along the y, they told us that 1 centimeter should represent 100. So 1 centimeter is just this one box here. So 1 centimeter, this one should be 100. So meaning, so here you need to be very careful. So meaning that here you have 100. This one is going to be 200. This one is going to be 300, 400, like that, like that. Now, when you look at it, you notice that your graph surely is going to be very small. But I've told you, never change the scale. You use what has been given to you. So for you complete, but here there is no need for me to go very far because I don't have any value above 400, even if I stop there. Kindly let me know whether we are on the same page. Okay, we are on the same page. Then, now, okay. What has happened? Oh, unfortunately, my work has gone out. Okay, no problem. Okay, no problem. Let me go back I'm just doing for demonstration. Now, after having your graph, the next thing you're going to do, you are going to start the plotting. So I want you to start your plotting. But I'm going to ask that for that we complete that task of plotting, but I'm going to show you the major things. Yes. So the most important thing was you to write the scale to have it. So I've showed you this is 1, this is 2, 3, 4, 5, 6, 7. Then they told us 1 centimeter should be 100. Like that, then I can stop there. So the first thing we are plotting was 0, 0. So allow me to plot the 0, 0. 0, 0 is here. I'll plot it. Then the next one was 1 and 31. Now, you need to ask yourself, if from here up to here, this is 0, this is 100, I have 5 boxes. What does one box represent? So I say 100 divided by 5, which is 20. That means that every single box here has 20. This is 40, this is 60, 80, and 100. Yes, Gavanian.
what I was asking is that when we are plotting, are we supposed to use the cross or the dot?
Now, in physics, you can use the dot. In math, you can use the star, you can use the X or the dot. Any can work.
Do we use a pen or a pencil?
I will recommend a pen.
A black one.
Now, in case you are in an exam, you don't mix colors. In an exam, don't mix the colors. Stay with your blue pen. Let me also go back and use blue. Yeah. So, yeah. Yeah. So that is it. Okay. Then the next one, because they may think that someone cheated for you, that someone came and inserted the answers for you. Then the next one was 1 and 31. We have said each box has 20. So 31 is going to be somewhere here. Then 2 was I think 40, somewhere here. Then the next one was the 3 and 42, somewhere here. Then the next one was the 4 and 52, somewhere here. Something like that. Yes, Milton.
Okay, so you say that we interchange the graph, yeah?
Yes.
So you are just doing this for demonstration.
Yeah, for demonstration. Because I said your 12 cannot fit.
All right, thank you.
Okay. Then the next one was 5 and 55, somewhere here. And then the next one is 6 and 56, somewhere here, something like that. Then when you reach 7, you notice that now they have started to decrease. They start going down. So you notice that at the end of that day, remember these quadratic curves, for any curve, we use a freehand. So I expect you to come here. I'm just doing this for demonstration to have your graph like this. Then when it reaches where 6 is, it bends down and then it starts going down like that. So something like this. That's how your graph is going to look like. But like I told you earlier, I noticed the number was not set so well. So the graph was very small like that. Yeah. Then after doing that, you also plot your line. Now the line we had was the negative line. So your line will cross like something like that. That's how it will look like. Yeah. Though I'll ask you not to, okay, you'll complete that. Then allow me to answer the next part, but good enough, I think you have got a hint on what to do. Then they ask, find the maximum number of bricks sold and the week this occurred. I told you that for the maximum point, you can just come here on your graph, after drawing your graph, and then check out at what point is that the values started going down. And if you notice that your graph is going to curve around where there is 6 here, where there is what? 6 to start going down. So those are the number of weeks. Then the number of bricks, you come and read off the corresponding value of y. So in the chart, if you look at where the curve is starting to go down, even if you just look in the table, even if you look here in the table, you'll come, okay. Even if you look in the table, but also I told you how you can calculate it roughly on how to get it. But since here they wanted us to get in the graph, don't show your calculations. You can show your calculations, you can do your calculations a bit outside. You say negative b out of 2a. Now you say this was your thing. My a was -1. My b is equal to 12. So I fill in here. I say this is negative. What was my b? My b is 12. Divide by 2 times what is a? -1. So this will give us -12 out of -2, which will give us the 6. So you'll find that the maximum point is at 6, or the week, it is in week 6. Then the number of bricks After getting this point, you can just feed it here to get the value of y. So here you note that at 6 weeks, we had our 56. So here it will be, you will say here that the maximum number of bricks will be 56 bricks, and it will occur in week 6. I don't know whether that is okay, everyone. Is that okay? Let me know whether that is fine. Okay. 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 Yes. Okay. Then from there, when you look at the second part, they are telling that on the same graph, estimate the number of weeks for which this one occurs. Now, many times when they give you this second equation, they have told us to plot two things. Now, I want to come back on these graphs we plotted. We had y is equal to this and this. That means this thing they have given you, it has some kind of relation with the first one. So when I come and arrange it very well, it is y is equal to negative x squared plus 12x plus that 20. Then what they gave us for our y was negative 2.5x plus 65. So when I get this y and I substitute it here where there is y, or alternatively, I can say I have y is equal to here when I am arranging it. Here under x squared, since it doesn't have x squared, I'll do nothing. Then I'll have negative 2.5x, then plus 65, something like that. Now, you notice that when I add these two equations, what happens? When I add, here I'll have 2y. This one will be negative x squared. This will be something, this will be something. You note that when I add the two equations, y plus y, here I'll have 2y. Then when I add this, this will be negative x squared. Then when I add this is going to be 12 minus 2.5x, it will not come out. 20 and the 65, you notice it is not going to come out. What about, so this is the first approach. Then you ask yourself, 20 plus 65, this one will give us the 85, I think. Then 12 minus the 2.5, I think it gives you what? Is that 8.5? What does it give you? 12 minus, 12 minus 2.5. But what I know here, the answer you're getting is not 14.5. Then, what about when you equate those two? When I have negative x squared plus 2x plus 20 equals to negative 2.5x plus 65. When you equate, what do you get? When I equate, what will happen is that this one can come this side. So I have negative x squared plus 12x plus the 2.5x, then plus 20 minus 65 equals to 0. So you notice that you have negative x squared plus the 14.5x, then this one is going to change. So that one is going to change. So now, when you are looking for solving here, depending on this question, what they wanted mainly was to come up with something like this. However, there was let me say, can I call it an error here according to what they really wanted. But still, do not say that there was an error. For you, did the way it comes out. So when you add the two, you'll notice that this will be negative x squared, 12 plus negative 2.5. I don't know what answer you got. I wanted to get that answer. That is what, 9.5. Move that to, okay, that is 9.5. 9.5x, then plus 85. So this is now what you come up with. So you note that now you're coming up with another quadratic equation. Yeah, even if you subtract the 2, so if you are to subtract the 2, this will be y minus y, which will give us a 0. This still will give you a quadratic negative x squared. 12 minus the 8, this one will give you the 8.5x. Then the 20 minus the 65, still that one will give you 20 minus 65. That one will give you around 45. So you notice still this is going to give you a quadratic equation that you have to draw again. Yes. So, yeah, so here you find that you have two quadratic equations. So probably there was an error here. But what they wanted to bring out was, the idea was where the two lines meet. So the best would have been either they would have, this one here would have been negative 20 minus 6, sorry, 20 minus 65. It would have been around negative 40 something. It would have been that way, negative 35. If it was negative 35, that would be very okay. So negative x squared plus 14.5x minus 35. If it was like this, then you'd have looked where the two lines meet. Yeah. Okay, yes, Sentomel.
I'm so sorry, teacher, to take you back, but I did not understand where this equation of 0 is equal to negative x squared plus 8.5 over minus. I don't understand where this equation came in.
Now, okay, are you saying in the question part C, this Roman 2,
Yes, please, teacher.
Yes, this is the equation. Are you seeing it?
Yes, please.
So they wanted us to solve it,
Yes, teacher.
using our graph. Yes, but according to the question, there is an error they made. I don't know.
Yes, teacher.
Yes. So they wanted us to use what we have already drawn to come up with a solution to this.
Yes, teacher.
But there is this one here would have been negative 35 for it to come out well the way they wanted it.
Oh.
So when you are solving the two equations, always there's some kind of relation. So when you look at the first one is negative x squared plus 12x plus 20. So one alternative you would have done, where there is y, you come here, here. Then you substitute. You say this is negative 2.5x plus 65 is equal to negative x squared plus 12x plus the 20. So when you collect like terms, take the 65 this side, it would be 20 minus 65 minus 65. So you get negative 2.5x equals to negative x squared plus 12x, then minus 35. Then when you take this one this side, it would have been negative x squared plus 12 plus 2.5, which gives you 14.5x, then minus 35, like this. So now this would have been the equation to solve. Now, friends, if this was the equation to solve, it means that you are going to come here on your graph. Remember, you had your graph like this, and then you had, let me say, a line like that. So the point where that line and the graph are meeting at this point here, you'll come, you read off the x coordinate. You'll come here, read off the x coordinate. Now those ones would have been the solution. But if it is like this, the way it is here, here, like the way it was given the question, you are going to go back. You are going to go back and either do one thing. One, eliminate. Let me now show you the other alternative. The other alternative is you come, you look at the equation that you have plotted, plus 20. Then you come, you arrange this equation they want you to solve in this form of 0 equals to negative x squared. This is going to be 14.5x and this is going to be 85. You arrange it in that way. So when you subtract here, you'll have y is equal to, here we'll have negative x squared minus x squared, which is negative x squared plus x squared, which is 0. So here we'll have 0. Then the next one will have 12 minus 14.5, which gives you negative 2.5x. So here we'll have negative 2.5x. Then the last one, you'd have 20 minus 85. So 20 minus 85 is negative 65. So here you'll have negative 65. So you'll have y equals to negative 2.5x minus 65. So now you go and draw this line here the way it is. So you construct a table, you draw the line, And then after drawing the line, you come on the graph you have drawn, you draw that line. The point where it meets, here down and here, is what you read off. Yeah. So there was something that was not right. Either this would have been negative 65 to bring out the idea they wanted, or you would have repeated. So, but that's how you could approach it that way. But now better, you go back on your graph, draw this line the way it is, negative 65, then where it meets is where the line is. Hope that is very okay. Yeah. Okay. Let me know whether that is okay in the chat. Yes, Gavanian.
Master, I was just correcting that 20 minus 65, it was negative 45, not 35.
20 minus?
65.
Yeah.
It
20
was negative
minus?
65.
It is 65, right?
Minus 65.
Hey, like 20 minus 85. I think it is negative 65.
No, Master. 20 minus 65.
20, 20, 20. What is 20? Oh, but the other previous one. Okay. Okay. Yeah. Okay, thank you. Okay. So I think we can now proceed. We can now proceed, but that's how the reason why we subtract, we want to eliminate this x squared. You use the other knowledge of simultaneous equation. If you want to eliminate, you notice that here the sign is negative, negative. The coefficient is 1, 1. You say same sign, subtract. So when you subtract the 2, you eliminate the x squared. So your aim always should be to eliminate the x squared. Okay, then based on your finding, assess whether the current model is sustainable. Now, looking at this current model, you can notice that the two models we are looking at, when you look at this model, you notice that in week 6, let me use week 6, we had 56. But when you look at the first model we had initially, when I go back, in week 5, they had sold 330 bricks. But according to this model we are using, in week 5, they have only sold 55. Then now, when you are making your conclusion, you base on that. In week 5, they had sold here 55. The other one had sold 330. So if you are a business person, which model would you go in for? So you can check that this model, here in your conclusion, you say, this model is not sustainable. And then give the reason, because in week 5, the sales would have very low of only 55 bricks. Yet in the first model, the sales in week 5 had gone to 330. So that's how you conclude. Is that okay, everyone? Let me know whether we are okay. That is okay. Yeah, yeah. So I've not drawn the graph because the graph was very small, but you draw it and then check out. Yeah. Okay. So I think we can now continue. The first model was there. The first model is here. When you check out the question, this was the first model they had. This one of the sequence, the one we developed, whereby you were getting 6 minus 3n. But I told you this n would have been x according to weeks. So it would have been 6 minus 3x. So they had two models, whereby y was equal to 6 minus 3x. Here, like I told you, you'd have related x to be your n. So this was the first model. And now this is the second model. So now you check out that the first model, you could get more. It was the linear model. This one was a quadratic model. Okay. Hope that is very okay. Yeah. So We can continue. We can continue. We can continue. Then, okay, we have another one here. We have another one here, whereby they're telling us that we have an engineer. Okay, you can first read through as I respond to Roche. Okay. Okay. Read through the scenario.
Excuse me, teacher. I'm requesting you elaborate more on the nth term number because I never understood.
Did you come like at the beginning or you found when we had gone a step? Roche?
I came at the beginning.
The beginning. Okay, I'm going to talk about it. But like I said, for the nth term, the thing that is very important is for you to know the arithmetic and the progression. Then we say that for arithmetic, that's where you look at the common difference. Then for the geometric, that's where you look at the common ratio. So that is the most important thing. Then from there, you go on and use those different expressions. Always first check, is the difference the same or the ratio? In case those two things are not working, now that one needs you to use another knowledge. Yeah, okay. But I think I'm going to share the recording such that you can be able to review. Okay. Now, when you look at this item, they told us that we have an engineer who was contracted by a certain hotel to design a new parking lot. On reaching the hotel, the engineer picked up measurements for two straight lines perpendicular to each other. Now, this is the most important word. Now, here, there is one, this item has the knowledge of equations of lines, whereby in equations of lines, in senior 3, you covered something concerning the gradient and you looked at the perpendicular. They are telling us that he had two lines, and when something is perpendicular, it means that they meet at 90. For the first line, the 2 points which he recorded were these ones. And for the second line, he picked up 1 point and recorded us at this. Then they are saying us, form the equations of the two perpendicular lines to help him develop an artistic impression. Now, in the chat, can someone tell us, or you can type, what do you remember about perpendicular lines? More so when it comes to the gradient. The product for the gradient of the is negative. Very good. Now we are going to first come and look at our two lines. 2 and -4, and then -6 and 9. Now the first thing we need to come up with is the gradient. And we know that the gradient for the first line, which we can call m, is always given by y2 minus y1 out of x2 minus x1. Feel free to label your lines that this is x1, this is y1, x2 and y2. Even if you had labeled them the other way around, it is still very fine. But do not forget, always it is y out of x. Now here our y2 is here, which is 9 minus y1, which is -4, divide by our x2, which is -6 minus x1, which is 2. Can everyone first come up with your answer? Come up with your answer. Come up with your answer. Okay, hoping people have got. So 9 plus 12, that is 13, out of -6 minus 2, which will give us -8. Now, whenever you get a fraction, to be accurate, please don't write point that maybe 1 point there. Leave it the way it is. So this one, I'll write it very good in a good way as negative 13 out of 8. Now, after getting the gradient, you know that for any two lines that are perpendicular, it means that the gradient of one line times the gradient of the other will always equal to negative 1. But since they told us to find the equations of the two perpendicular lines, I'm going to first find out the equation of this line. Yes, Elk.
Why did you move that? Negative to 13.
Why do we? Oh, I have just moved the negative up, because it's like having down here, it looks a bit ugly. So that's why it is better to write it up.
Okay.
So writing out of, because we have already divided 13 divided by negative 8, which is the same as negative 13 of it. But these two are the same. Okay. And then I write the equation over the line. Now we know the equation of the line is given by y. I don't know which approach you want, but allow me for me to use this one. We know that y is always equal to mx plus c. Now our gradient is negative 13 out of 8, so I will say y is equal to negative 13 out of 8x plus c. Now for the first line, pick any point of your choice. It is okay. Now for me, let me pick on this point of 2, 4. So I will say the point I've picked is 2, negative 4. And why are we picking? Because we want to obtain c. So this is your x, this is your y. So where there is x, put 2. Where there is y, put negative 4. So I'm going to say this is negative 4 equals to negative 13 out of 8 times my x, which is 2, plus c. Feel free to first reduce here if you want. If you don't want, if you are not comfortable, first go on and simplify. Say negative 13 times 2, which is equal to 26, or negative 26. That is very, very okay. So I'm going to come here and say this is negative 4 equaling to negative 26 out of 8, then plus my c. Now your task is to find c. So if you want, you can carry this the way it is this side. So you can say negative 4. Since this side is negative, this side becomes positive. Plus 26 out of 8 is equal to c. So can someone just add for me negative 4 plus 26 out of 8? What do you get for your answer? Negative 4 times 8, that is 30. 8 times 2, that is 32, negative 32 plus 26. Okay, that is negative 6 out of 8. So I don't know, for me here, I'm getting negative 6 out of 8 equals to c. Do we have the same for your c? So when you reduce by 2, 3 by 2, 4. So our c is equal to negative 3 out of 4. Gavanian never write points. Now let me put it that way. Don't write points because you are going to get an inaccurate answer. So leave everything in fractions. Most so whenever you get those non-terminating decimals, better you leave your answer in fractions. So here I'm going to come and I say, now my c is equal to negative 6 out of 8. And when I reduce, I remain with negative 3 out of 4. So I come back and say, but my equation was ymx plus c, and we had our gradient as negative 13 out of 8x, then plus my c, which I've obtained as negative 3 out of 4. So which you can write in a good way as negative 13 out of 8x minus 3 out of 4. So you leave your answer like that. I don't know whether that is okay to everyone. Is the first equation fine? Is that okay? Okay. Okay, it is there. Okay, then to get the second one, we have, since they gave us only 1 point, we need to use this one. We shall say that for perpendicular lines, for two lines that are perpendicular, for perpendicular lines, we know very well that the gradient of the first line times the gradient of the second line will equal to -1. For lines that are perpendicular, so the first line had its gradient as -13 out of 8 times the gradient of the second line we are looking for will equal to -1. So what am I going to do? I'm going to remove the 8. So you can multiply this side. You can say multiply by 8, multiply by 8. So you remain with -13, m2 equals to -8. Then after you divide by -13, divide by -13. So your second gradient will equal to this negative and a negative cancel. So you remain with 8 out of 13. So that's what you get for the gradient of the second line. Now, after obtaining that gradient 8 out of 13, I'm going to come here and say my M2 is equal to 8 out of 13. So you go back and get now the equation for the second line. Since they gave you the point -4 and 6, so you know y is equal to mx plus c. Now find your y. This is your y and this is our x. So where there is x, we are going to put -4. Where there is y, we put 6. So I'm going to say 6. Our m, we have obtained 8 out of 13 times our y, which is 6 plus c. Can everyone get c at least? For say you don't want to work it out, can everyone get c? And you can put for us in the chat. So we are calculating for C now. Okay. Oh, okay. I had seen someone's hand up. Abigail, what do you have? You can punch it in your calc. Yes, Emma?
Sir.
Yes.
Sir, I think that here where we said that y is equal mx plus c, then we said that x is equal to 8 out of 13. Then that one it is 4, it is not 6, sir.
Okay, thank you. So this is -4. Okay, thank you. Okay, so calculate and we see what you have. -24 out of 13. Okay. So let me wait for people. I think they're still calculating. 110 out of 13. Remember, it's not -24. No, it's not -24. Okay, Zoom users corrected it. 30 minus 13. Oh, okay. Remember, at this step here, I expect you to say this is going to be 6 is equal to 8 times -4, which is negative. That is what? 32 out of 13 plus c. Then you take it the other side, you say 6 plus 32 out of 13 equals to c. Then you get your c. But I've seen an answer that is okay in the chat. Looking through the chat, 30 out of 13. People are getting 30 out of 13. How are you getting 30? People, let's add very well this one. 6 plus 32 out of 13. Because for me, I'm getting this is 13. Then this is 6 times 13 plus 32. And surely when I do, Lizzo is getting 110 out of 13. Yeah, at least I agree with Lizzo. It is 110 out of 13. The rest, please check out. Check out whether that's what you have. I don't know that it is clicking now or not. Please add well whether now it is coming out. Add well. Okay. Yes, now Virginia, I think that is also okay. But when you are writing your final answer, do not write mixed numbers. Do not write mixed numbers. Leave it as a fraction. Okay, many marks. Let me hope that is okay. Okay. Now, after obtaining your C, we are going to write our final equation, and we say now our equation B, our M, which was 8 out of 13 x plus C, which is 110 out of 13. So that one is our answer. Then remember, you respond back. So we are going to go back and respond and say that form the two equations of the two perpendicular to help him develop an artistic impression. So now there you conclude and say the engineer will use these lines, or the engineer will come up with these lines. So you mention the first line and you mention the second line. So those are the two lines you can mention. Then, here, those who want to do things, you can even go on and say 13y is equal to 8x plus 110. That one is also okay. Yeah. So, but these are the two lines that the engineer will use. Are we good to continue? Let me know whether now we can continue. Okay. We continue. Then the second part, they told us that determine the measurements of the rectangular lot. Now, this is where now we are going to bring in. Remember, many of these items, they will mix quite a lot of things. So you need to be well conversant with all the topics. So here you have noticed there was the knowledge of equations of lines. Now, the next part requires you to have something different as well. So in the second part, I want, okay. Let me first make a do. Let me do something here. Okay. Okay. Now we are going to interpret together the second part. They told us that the new parking lot is to be a rectangular in shape. Draw that one. Make a sketch that this is the new parking lot. The new parking lot. Wherever you can draw things, you make a drawing. With its breadth 3 meters less than its length. This is our length and this is our width. So they have told us that its breadth is 3 meters. Breadth is like the, let me say the width is 3 meters less than its length. You tell me, if here I have put 10 in the chart, what would be our width? If our length was 10, what could be our width? Just imagine like that. People have got 7. Very good. Now, if I put here, members, let me put here, let me put our length, let me give it unknowns, since we don't know it. So if our length is y, what would be our width or breadth? Write for me your answer now in the chat again. Patricia, good. Danny, that is okay. Milton, Kathy, yes. So here our breadth, everyone, Liz, Menel, yeah. So this one would have been y minus 3. Very good. Now that is the first step. Then we continue. Its area is to be 4 square meters more than the area of the odd parking lot, whose shape is in form of an isosceles triangle of height 12. Now we are going to make another one. Now here they are telling us that they had another odd parking lot. This is the odd parking lot. Now you need to know, what do you know about isosceles triangle? Because that one is a keyword, isosceles triangle. That for something to be isosceles, what do you know about it? Let me see whether people can put for us something quickly. Isosceles, two sides are equal. Very good. So mean that this side and this side are going to be equal. Very good. Then they went on and showed us that of height 12. So the height of this is 12 meters, with its base as the breadth of the rectangular parking lot. Hope you have got that. The breadth of this isosceles triangle is equal, with its base as the breadth of the rectangular plot. So members, let me know, what is going to be the breadth for our rectangular there? What shall we put? What are we going to put? What are we going to put there? Y minus 3. That's Patricia Shamran. Very good. So here we are going to put y minus 3. Yes, Danny, that's okay. Now, after doing that, it means that we are on track. The next one, do not forget to define that. Let the length of the new parking lot be y. Now, after doing so, here, when you notice, they are comparing areas of two figures of the new parking and then the old parking lot. So, we are going to first find out. They told us that its area is to be 4 square meters more than the area of the old parking lot. So, I'm going to first find what is the area of the old parking lot. So, I'm going to say area of old parking lot. And we know that area is given by a half. When you look at the odd, this is a triangle, so it will be the base times the height. So here we shall have a half times our base, which is y minus 3, times the height, which is 12. So when you try to reduce, by 2, 1, by 2, 6. So, but I've told it is not good to show. So for me, there is no need for show, but I'm just showing for clarity. So here, I'll have 6 into y minus 3. So when I try to open the brackets, I'll remain with 6y minus 6 times 3. That is 6 times 3, which will give us the 18. Kindly let me know whether this is okay to everyone in the chat. Is that fine? Are we on the same page? People are saying yes. Good. Now we go to the new. We are going to go to the new area. Now, area of the new parking lot. Now, how do we get the area of the new parking lot? Because they have told that the new parking lot, its area is going to be 4 more than the old area. Hope that is okay. It's going to be 4 more than. That means that area of the new parking lot is going to be the old parking lot, which is 6y minus 18, then plus 4. Members, is that step fine? What I'm doing? Yes, so now here we are going to come and say the new parking lot is 6y minus 18 plus 4. Because they told that the new parking lot, this is our new parking lot. This one here. Are you seeing? This is the new parking lot. Its area is going to be, when I get the area of the old parking lot and I add on 4, I'll get the area for this. So we have already obtained the area of the old parking lot. So to get the area of the new parking lot, I'm going to add plus 4. I don't know that now it is clear. Proscovia. Is it okay now to everyone? It is. Yes. Let me first speak on Tracy. Yes, Tracy. Tracy?
Teacher,
Yes.
it is clear about that you're adding 4, but where is the 4 coming from? Is it that the figure it has 4
Here. Angel, from here,
Yes.
its area is to be 4 square meters more than the area of the old parking.
Whoa.
Hmm.
Okay, thank you, sir.
Okay. So here I'm going to come and I will say this is going to be 6y negative 18 plus 4 will give us minus 14. So, but we are going to ask ourselves, what is the area of the new parking lot? Now, to get the area of the parking lot, you know very well that you multiply the length and the width. So the area of the new parking lot is going to be the length times the width. And this one should equal to this. So when I open up brackets here, I'll have y squared minus 3y equals to 6y minus 14. Are we still on the same page? Or we are leaving someone? Still the same page? If we are still on the same page, kindly correct for me the like terms. Correct for me the like terms. And then you tell me, you show me your final quadratic equation. And remember, the moment you say a square, that is a quadratic equation. So you correct for me the like terms, and then you tell me your final equation. Lizzo?
Teacher, it's x squared minus 9x plus 14.
Oh, you used Excel?
Yes.
Okay, it is?
X squared minus 9x plus 14 is equal to 0.
Plus 14 is equal to, like that?
Yes.
Okay. Which method are you going to use to solve?
The one for the square root, gotten its name, that one.
Okay, that one. Okay. You solve for us. But here, allow me to stick to y since we had used y in our question. So go on. What is your A?
My A is 1. B is negative 9. And C is negative 14. I mean positive 14.
Okay. What is the formula?
X is equal to negative B plus minus square root B squared. Is it minus plus? Minus 4AC out of 2A.
Okay, continue.
So B is negative 9, so negative 9 plus minus root of 9, negative 9 squared minus 4 times 1 times 14 out of 2 times 1. It's going to be positive 9 plus negative plus minus negative plus minus negative 9 times negative 9 is positive 81 minus 56 out of 2. Okay, 9 plus minus root of 25 out of 2 is going to be either 9 plus 5 out of 2 or 9 minus 5 out of 2. This gives me 9 plus 5 is equal to 14 out of 2, which is equal to 7. 9 minus 5 is equal to 4 out of 2, which is equal to 2.
Okay, thank you.
Welcome.
Mm. So when we go back, we have to, they told us square meters. So do not forget that your units they are going to be now in meters. Then 2, we are going to reason out. We are going to reason out. On the 2 answers, which one are we going to take on and why? So feel free to raise up the hand and you tell us this one and this is the reason. Okay. Yes, people are mentioning 7, but I want to know why are you taking on 7? Okay. Let me take on, yes, Menel.
I think we are going to take on 7 because if we fill in the equation whereby we're drawing the dimensions of the length of the new area, and one of our dimensions had y minus 3, and we know that dimensions should not have negatives. So if we take on 2, we shall have negative 1 as our dimension, yet we are supposed to have positive dimensions. That's why we should take on 7.
Perfect. Thank you. That is very correct. So that is the reason, members, because here when you say 2 minus 3, it will be negative 1. Yeah, so 2 cannot be our answer. So in your conclusion, you cannot take on you can't take on 2 much as it is a positive. So here when you are making your conclusion, then you need not to take on. Now, remember we have to conclude. We have all obtained our length. Can you obtain your breadth as well? Obtain your breadth. Obtain your breadth. Yes, Samsung.
Teacher, I have a question. I'm lost whereby we're saying y into brackets y minus 3 close brackets, and our final value was y squared minus 9y plus 14. What I thought was we were going to get y squared plus 9y.
Okay. Was the opening okay for you?
Yes.
Now, are you seeing this 6? When we take it this side, are you seeing?
Yes.
This side it was positive. When it comes this side, it becomes minus 6y.
Yes.
So negative 3 minus 6. That's how we get the negative 9.
Okay, thank you, teacher.
It is okay now? Okay. Hope Samsung it is well. So that's how it comes about. Now, someone is asking, is there any question or scenario that may ask you to use a specific method? No, they may not ask you that use a specific method. However, it's going to be from your own understanding that in which element of construct is this scenario, such that you use the appropriate method depending on where that item is. Like yesterday, take an example. In case I'm in this element of construct, feel free to use any method of use. You can use this bulldozer, you can use completing squares, you can use the factorization. Any approach that is easy for you, it is the one that you go in for. But you should be mindful of the time. But they may not specify that use this method, use this method. Yes, unless otherwise. But we expect that a learner goes with the approach he or she understands, but also she must be able to understand that this is where we are and this would be the appropriate method. Yes. Okay, so in your conclusion, anyone who wants to conclude for us, how would you have concluded for this item? Yes, Milton?
Thank you, sir. For me, I was taking you back on part A. I was asking about how you got 110 over 13. I'm still confused. Highlight more on that.
How we got
Yeah,
100?
110 on the next let me see here. How we got 110 divided by 110 over 13.
Okay, remember we had 6 plus 13, sorry, 32 out of 13. Is that fine?
Yes.
Now, when you look at this, what is your LCM?
13.
13. So 13 by 1 you get?
13 divided by 1, huh?
Yeah, is 13.
13.
Then 13 times 6. Is that okay? Plus 13 divided by 13 is 1. Then times 32.
Okay, thank you, sir.
Okay.
I've got you now.
Okay. So, someone, I think I'm going to also call on. Yes, use any method that is easy for you. You can use bulldozer, you can use factory. Oh, Chisache Mark, I thought, no, Chisache, it was a plus. It was a plus. Remember, this side, you had a negative here. It was negative here. So when the negative comes this side, it becomes a plus. I don't know that people have seen it. Remember for that particular item, you had your y was 8 out of 13 and our x was negative 4. From here, then plus the c. So 8 times negative 4 is negative 32 out of 13 equals to y. So y was 4, sorry, was 6. So when this negative comes this side, it becomes a positive. Okay. Oh, okay. Now I'm seeing what people confused. It was 6 plus 32 out of 13. But people, I think, just added 6 plus 32. Okay. Yeah. So hope Marita now it is okay. Yeah. Okay. Now we can continue. So here your conclusion would have been maybe the the length, because they asked for measurements, they did not ask for the area. So you say the measurements of the rectangular parking plot would have a length of 7 meters and a breadth of 4 meters. So that's how you would have concluded for that. Do not forget to respond back to every item whenever you finish. Okay, that is one. I think we can continue. Read through this as well. Read through that item as well. Okay, now after reading through, you let me know. Should we do it as homework or you want us to do it now? Let me know through the chat what you think.
Remo, nkya kuyita oggulewo.
Homework, okay. So some want to do it as homework. Yeah, we can. Okay, let me first read through a bit your comments. Okay, let's take a screenshot and then we are going to try it. Homework. Okay, now let's take a screenshot of it and then we try it out. But one thing now I want you to know about this particular item. When you read it, some of you may interpret it as proportions. Others may interpret it as something, but there are some keywords you look out for. The word like a constant rate, the same rate. Same rate means it is linear. There is linearity. So here, if you find such an item on item 2, it means that the best approach to use is using the idea of gradients to form an equation of a line. The moment you see same rate, constant rate, it means it is linear. Now, some of you may make a mistake and go and say distance is speed times time. What? Remember your distance, speed, and time. It is in another element of construct. So here, much as your answer will be the same, but you have not applied. You have applied your knowledge in a wrong area. So you need to know which knowledge should I apply depending on where the question is placed. So you are going to try it and then you let me know what you would have obtained. Okay, then I want to, okay, so people have said we can. Okay, then this is another one I want you to try out. Okay, now I'm giving you homework. This is your homework again. This is another number you can take. Still the item I showed you, that those are item 2s. We are only doing item 2s. So those are possible item 2s depending on the question. Hope people have taken a screenshot of that. Okay, I don't know whether I have another one. I have another one here. Also take a screenshot. That one is also homework for you. Okay, hope people are finished. Okay. Now, those are the ones you are going to attempt. Now, okay. So, looking, okay. So what are we going to do? One, I want you to look very well at this element of construct. So we have looked at a bit of sequence and patterns, and I've told that under this, know whether it is an AP or whether it is a GP. We have looked at a bit of equations of lines and curves. So here I expect you to be able to know how do you calculate the gradient. You need to know things concerning the perpendicular bisectors. Then under algebra 1, here I expect you to know how do you collect like terms. That is the most important thing. How do you solve quadratic equations? Then under mappings and relations, unfortunately, we have not looked at any number. But here under mappings and relations, you need to remember you need to remember things concerning the domain and things concerning the range. That is mapping and relations. Then you need to know under what circumstance is something called a function. Is it a one-to-one? That yes. So you need to know something concerning mappings and relations. Then you can look under vectors. Oh, wait, let me give you a number on this. I saw a number in one of the seminars. Let me just show you a number on that. Probably you can take a screenshot of that number on that item. So I saw this. Hope you can see under mappings and relations. So we can first read through this on mappings and relation. This was the item. So read through and we can take a screenshot. After reading through, hope people are finished to go through. Now, those who have finished, I think we are good to continue. So they gave you the cost and then they told you that considering the mapping rule, find the cost of purchasing a 3 GB. So here, I do expect that now someone is going to come and say, my C cost is equal to this plus the 2000. Then you come find the cost of the purchasing a 3 GB. Then you substitute. So you first say 3, and then do not forget to show this when you are finding those functions. Then you say times 3 plus the 2000, and then you get your total. The same with this. Then when it comes to part B, they wanted you to find a GB. Then that means that you'd have substituted this where there is the cost and find the value of X. Then here, they asked you to represent on a mapping diagram. So let me hope everyone still remembers how we draw the mapping diagrams, whereby you're going to find here, this is your domain and this is your range. You put here all your X values, 1, 2, 3, 4. Put here the cost, and then after you map. Do not forget to put here your rule you have used. And do not forget that when it comes to the range, we don't repeat any value. Then they ask whether the relation is defined in the domain is a function. Then you say, yes, it is a function because every element in the domain maps to exactly one element in the range. Or every X value has one, every input has only one output. So that's how you attempt such items when it comes to functions. So take a screenshot. Okay. Then I can continue. So that is what you needed to know about that particular item. Allow me to first stop because then I go back to my screen here. Then when it comes to this, so that was mappings and relations. Then you need to know about vectors. Now here, vectors and translations. Do not confuse this concept with the concepts in transformations. Here under vectors and translations, this is where they can tell you that this person was translated by vector this and this. So here under translation, what you need to know that anything with translations, we add. So this is where you have to say a translation vector plus object is equal to image. So here you need to know that translation plus the object will always give you the image. Here is the vector, this is the object equals to the image. Then we looked at inequalities and regions. Here the major thing you need to know is the shading. How do you shade? That this is a side-eye shade, this is a side-eye shade, but also they can give you when they have drawn, when they want to test for multiple concepts, they can give you your things drawn very well, they have shaded, and then they ask you to find the lines he had drawn or the lines he has that generated those inequalities. So you need to know if your graphs are drawn, how can I obtain the equation for each of the lines and determine the right inequality they used. Then make sure you know how to solve the spontaneous equation using any of the methods. But yesterday I told you, or I advised, that whenever you are in item 2, we do not expect you to use the matrix method because matrices is an application in item 3 and 4, or that element of construct in section B. Then here under quadratic equations, know how to draw them and know how to draw them, and also how to I wanted to give you a question on quadratic, but know how you can draw them. And yeah, that is very important, how to draw them and how to use the formula. Allow me to give you here a question on quadratics, but those who accessed the help questions for the seminar, you will check out that item. I don't remember the item, but also you can also check it is in New Vision somewhere, but it was like this. I gave something like this, and it was saying that during sports day, Solomon throws a javelin. The height in meters was this, and I told them that you show the path taken by this. So I was asking that you draw the graph for that. And after I asked what could be the maximum height the javelin reached. Then from there, I put something. So you can, this is the quadratic equation, but I was asking to show the path taken. So I expected you to be able to draw that curve. Now this one being positive, it will look like that. So no, but this was supposed to be negative. Put here negative because the javelin goes like this. So that's how it was supposed to look like. Yeah. So you can check out those helps seminar questions. There was a question on quadratics. Then composite functions. I remember we did this together in January. So you can check out and then be able to do things concerning. Then now tomorrow we are going to concentrate on linear programming. And tomorrow I'll concentrate on mainly mock papers, many of those mock papers where I saw a lot linear programming. But remember also at this point, linear programming can be combined. They can combine linear programming and composite functions. They can combine linear programming and quadratic equation. They can combine linear programming and any other topic. So you need to be very active in all the different topics. So tomorrow we are going to concentrate mainly on linear programming, and tomorrow we are solving those linear programming equations, meaning you need your graphs and a mathematical set. Okay, yes, Angel.
Sir,
Angel?
for me, sir,
Yes.
for me, I just wanted to give a closing prayer when we are done.
Okay. Okay. Kali. So this is what I do expect you to do. So tomorrow, so try out those numbers. But before even we go, allow me to elaborate on this number because we may not get a chance. Yeah, but at least someone may. This number here, I wanted to say something about it. More so, here on this, on part D, they asked, find the greatest number of people the committee is able to invite. Now, this one requires you to use inequalities. So after forming your equation, let me say this is the equation you have formed. When there's the greatest number, that is the maximum, we expect that the equation you're going to use, you will use less than or equal to, then you put the number. Yeah, so I don't expect you to use equal signs. Yeah, so I think let's end here because I'm going now for senior 5 and then we shall start from here. See you tomorrow and have a good day. Oh, the prayer. Angel, lead us the word of prayer. Sorry. Angel, you wanted to lead us?
Okay, humble yourselves for that prayer. Loving Father, we thank you for the gift of today. We thank you for the gift of our lives. We thank you for each and every chance that you have given us to have this lesson, O King of Glory. Father, we are sorry wherever I have gone wrong, O King of Glory. We thank you for the gift of our teacher, and we pray you bless him more and more, and our other teachers, O King of Glory. You give them courage and love and morale for teaching us, O King of Glory. Father, we thank you for these lessons, O King of Glory, and we pray whatever that we learn, O King of Glory, may keep it into our memories, O King of Glory, so that if a time comes and we have to respond to something like this, we may be able to respond to it, O King of Glory. Father, we thank you for this day. We thank you for this great moment you have given us, O King of Glory. And I pray as some of us we are leaving for school, you may lead us, guide us, and you protect our friends and our teachers. In the mighty name of Jesus Christ, our Lord, I prayed and believe. Amen.
Amen. Thank you so much. Okay. Marita, I don't know whether the Gavanians are still on. Gavanian, kindly have your video on if you don't mind. I want to keep it here. Yes, Marita.
Sure, good morning once again.
Yes, good morning.
Sure, my brother is dying ever since I started Zoom lessons to say hi to you. Then. Even me. Hi.
Hi.
Hello.
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 So, thank you, teacher.
Okay. Yeah.
Yeah, that's all.
Okay, Marita. Send my greetings to them.
Sure.
Okay.
Hello.
Okay. I want to first get the what? The Gavanians here. Okay. Okay. That's the first group. Is there another group? Oh, it is one. Okay. Okay. Thank you, Gavanians. See you tomorrow.